In this problem, we're told that we have an initial investment of 335,000 and that it lasts for 9 years. And then in the coming 9-year period, we have expenses of 6,000 which are incurred at the end of each year. And then we have an income that is received annually in arrears. And this term over here in arrears, it means the exact same thing as at the end of each year. So essentially it means at the end of each period. So this is just to test you on terminology. If you see this again, just remind yourself it means the same thing as this at the end of each year. And then the income is received at an annual rate of 50,000, and then it will increase by 4% every 3 years. And then we need to find the discount payback period. And we need to prove that the discount payback period is 9 years at an interest rate of 4%. So when you're told to prove the discounted payback period is a certain year, so in our case it's 9 years, all you have to do is just to prove that the present value at 8 years is negative and the present value at 9 years is positive. And if you can show this, that means time 9 is the discounted payback period. So in that case, that means all we have to do now is to try to find an expression for the present value of everything that's going on. So we remind ourselves that at time 0 there is an outward investment of 335,000. So here there is an outward investment of 335,000. And then let me just break this up into 3-year periods. So it's 1, 2, 3, 4, 5, 6, all the way to 9. And then within this period, the income is 50,000 per year. So we're receiving 50,000, 50,000, and then 50,000. And then there is also an expense of, as given here, 6,000. So there's also an expense of 6,000. And then within these 3 years, so from 4 all the way to 6, the income is going to increase by a factor of 4%. So that is given to us. So the income in these 3 years is equal to 50,000 times 1.04. And it applies again to these 3 years, 4, 5, and 6. And then again, there is going to be an expense. And then for years 7, 8, 9, we get something similar. 50,000 times 1.04 to the power of 2 minus 6,000. So now all you have to do, so this is all the cash flow that is going on. And then just looking at this diagram, we can actually just group this up into these components. So because of there's the 1.04 over here, this complicates things a bit. And in order to kind of incorporate this 1.04, we can actually just kind of bring the present value of all this. So say for this expression here, we're going to bring it back to time 0. For all this payment here, we're going to bring it back to time 3. So we're going to do it at different viewpoints. So the payments over here, we're going to stand at time 0, and then the present value of all those payments will be 50,000 minus 6,000 times A3. So this term here summarizes everything that's happening here. And then for these payments, we're going to bring it back to time 3 first. So we're going to stand here, and then we get something similar. We have 50,000 times 1.04 minus 6,000 times A3. And then of course we want to bring it back to time 0. We're standing at A3 now, so we multiply by v to the power of 3. And then we do the exact same thing here. Now we're standing at time 6, and then we're looking at these payments at time 7, 8, and 9. And then we just do something similar. We just apply this formula, minus 6,000 A3. And this expression is what you have when you're standing at time 6. Bringing it back to time 0, we just multiply by v to the power of 6. And then don't forget there is also the initial outlay. So this is the present value at time 9. And then if you substitute all the numbers in, remember this is evaluated at an interest rate of 0.4. Once you substitute all the numbers in, you find that this is equal to some positive number. Actually, this number doesn't really matter. All we have to know that it is positive. And so essentially we've proven this. So now we need to show this. We need to show that the value that you have at time 8 is smaller than 0. So present value at time 8 is really just a slight alteration of the expression down here. So the present value of time 8, so we're just going to start with the initial outlay. So of course, at time 8, we're going to have to include this. And then at time 8, we're going to have experienced these cash flows at time 1 to 3. And certainly these cash flows at time 4 to 6. So just remind ourselves, these are the cash flows from time 4 to 6, these are the cash flows from time 1 to 3. And then for here, the cash flows from 7 to 9, because we're only calculating up to time 8, we don't need to do A3 here. So we need to slightly alter this a bit. So minus 6,000. So this time it's A2, so we only have 2 payments here. Well, only counting up to A2. But then this expression here, this is the present value of what we have standing at time 6. So we still need to bring it back to time 0. So the only difference here now is that this is A2 and this is A3. And once again, you substitute all your numbers in, and then you'll find that this is equal to another certain negative number. So once again, the exact value of this number is not important. All we have to know is that it's smaller than 0. So we've proven both of these claims. And so that is why the discounted payback period is equal to 9.